Hi class, today we're going to be discussing equations for chemical reactions. We're starting chapter 7. So equations have to do with chemical changes. Here, a chemical change occurs when a substance is converted into one or more new substances that have different formulas and different properties. So here's a picture of nails. We see nice shiny nails that are made of iron, but if you find an old rusty nail and it's really rusted, it'll eventually start to crumble away. It will not, it's being eaten away slowly. Sorry, that's spam. Probably about an extended car warranty or something. So as it's starting to be eaten away, it will eventually just it will be no more of a nail. It's gone. And this is a chemical change. What you started with is not what you're ending up with, and that means there's a chemical change. Something happened to change whatever you initially started with. So nails being rusted away is a good example. For instance, I'm a huge Titanic fan. James Cameron has already stated that he doesn't believe that Titanic will be around for even 20 more years. So those parts that have shown already being rusted, he said the more times that he's gone down, he's seen more and more of it just disappearing. It's gone. And he believes in 20 years, those parts that are iron, made of metal, that can rust, that they're just going to be gone. Chemical changes. So a chemical change occurs when a substance is converted into one or more substances with different formulas and different properties. May be observed by the formation of bubbles, a change. So we'll cover that one. That's on the next slide. So let's make sure you understand a chemical change. A chemical change, and I have in a box, because this is what I did as a student, is I would ask myself, if I get confused about chemical changes, the substance that I'm starting with, do I have that after a change has occurred? Now, we can have physical changes, we can have chemical changes. So which one are we dealing with here? So for instance, we'll go back to the picture. Let's say you have a piece of paper and I rip up this piece of paper. After I've done some action to it, is my paper still a paper? And the answer is yes. I could pull that paper and tape it back together and it is still a piece of paper. So I still have my piece of paper. It may not look great, but it's still made of the same compounds. Nothing changed within the actual compounds that made up that piece of paper. Now, if I take that piece of paper and I throw it into a fire, once the fire's out, do I have the same substance? Can I go in and pull those ashes out, tape them back together, and call it a piece of paper? I could, but it's wrong. It's not a piece of paper anymore. Those elements that created that made up that piece of paper have now switched partners, in a sense dancing partners, and created a new compound. So what I have now from a piece of paper is I have ash, I have water vapor, I have carbon dioxide, I have other compounds that have been created. So when I ask myself this question on here, the answer is no. A chemical change occurred. It is no longer the same substance. And here, when we look at silver and silver sulfide, you can see that silver here is really pretty and nice. But as it starts black, it's getting black, that's tarnishing. It's actually being eaten away. This is why you have to polish the silver so it doesn't start tarnishing. It's slowly changing into silver sulfide. Same as rust. It eventually will just be that those layers will go slowly till they're not existing anymore. It's tarnishing it. So if we were in the lab, you would understand this section very well, but unfortunately we're not. And that's the downside of being online, is that it tends to stick in your memory better. If you're physically doing this stuff, you can relate to it easier, but that's okay. We're going to go over it here. So any change, so if we started with something and we caused an action, we put an action to it. And when we look at the final product, is it still the same thing? Color indicates that a chemical reaction occurred. So anytime you see a change in color, 99% of the time, and for this class, what we would give you is going to be considered a chemical reaction. So if the color changes on something, it's a chemical reaction. Next one is gas, bubbles. When you see bubbles, that's a gas escaping from the compound or solution, whatever we're working with. Bubbles are evidence of a chemical reaction. So something's happening and the gas is usually either hydrogen gas or oxygen gas being emitted, and that is leaving the compound of what's newly formed. The third one is solid. A precipitate is formed. So in this case, a yellow solid forms when potassium iodide is added to lead nitrate. So you have these two clear solutions and you add one to the other and instantly you start seeing color. This is evidence of a chemical reaction. A substance is being formed. And the last one is heat. This is the one that's a big deal if we were in lab, because you could actually feel, we don't do, you could put your hand on the side of a beaker if you were doing a chemical reaction, and two things would happen. You would either feel heat, not enough to burn yourself, but you could feel heat being transferred to your hand, like a heat warmer, or you would feel heat being leaving your hand and going into the beaker. It would be cold. And that's a sign of a chemical reaction as well. Heat is either being released as new substances are being formed, or it's taking in energy to create those new substances. So writing a chemical equation, we start out with reactants and we start out with and end up with products. So here we have one carbon atom, two oxygen atoms, and on the product side we have one carbon atom and two oxygen atoms. So this is where you can visually see that you cannot create something out of nothing. Whatever you have on this side has to be on this side. It is 1 and 1 for carbon and 2 and 2 for oxygen. And that's what we'll be doing today, is balancing equations. So whatever you have on one side has to be on the other. You cannot have carbon on one side and oxygen and then gold on the other. Doesn't exist, cannot happen, breaking all rules. Has to have the elements and they have to be numbered on the same side. Can change partners, but have to have the same. And we also include physical states. This, I know when you first learn it, it's very irritating. But as we start doing more and more with this, those physical states help you a lot when you need to answer questions. So here is, we're going to go over what you need to know to write a chemical equation. So we have reactant side and we have a product side. And in between is an arrow. And that arrow means that a chemical reaction has occurred. Something is yielding. Yield means producing. So usually we'll say produces. So if I was to go back on this one, I could say solid carbon with oxygen gas produced carbon dioxide gas. So that's what this means. Or yielded, resulted in. Those are all meaning the same thing. So the tip of the arrow goes towards the reactants. So this takes the N side. And the arrow is pointing to what has been newly formed from the reactants. The reactants are written on the left of the arrow, so the back end of the arrow, and the products are written on the right. The tip of the arrow is facing the product side. We can have multiple reactants and multiple products. For this one, we had 2 reactants and 1 product, but we could have 1 reactant and 2 products, or 2 reactants and 2 products, and you get the idea. It doesn't matter as long as it balances. And if it's heat, you will usually see a triangle above it. So this indicates that some heat caused this reaction to occur. The heat was needed in order to push this reaction to occur. And the physical states are always we put the parentheses and we put solid, liquid, or gas, and aqueous. Aqueous is a solution dissolved in water. For instance, vinegar, you would put it as aqueous, something like that. Hydrogen peroxide is H2O2, you would put aqueous. And that means that a substance dissolved in water. It's not just a substance, it's dissolved in water. Acids are one thing that we put with aqueous. HCl with AQ, hydrochloric acid. So your book has this. It's 7.2. Shows you everything I've just discussed. So if you need to refer back to this, it's very important to make sure you understand. And one last thing I forgot to mention is a plus sign. A plus sign is used to break up the reactants to show that there are more than one reactant in between, or more than one product in here. So if you see on this one, the reactants had 2 reactants and 1 product. So a plus sign wasn't needed on the product side because there was only 1. All right, so now we're going to start balancing equations, but we need to first identify with it. So on this side, we have 4 hydrogen atoms on the reactant side, and then we have 2 oxygen atoms. And over here we have 4 hydrogen atoms, and we have 2 oxygen atoms. So there's a few things you need to, nothing is created nor destroyed. So like I said, we can't have this and then produce gold. We have to have the elements on gold on both sides, and they have to balance, or it doesn't exist. So no atoms are lost or gained. So we'll never have 4 hydrogens and then 3 on this side. that's wrong. Doesn't exist. Something's wrong here. You have to balance it out. And that's what's going to happen. You're going to have unbalanced chemical equations, and you're going to have to balance them. The number of atoms on the reactant side is equal to the number of atoms on the product side, which is exactly what I wrote down here. So they balance whatever elements you have on one side, you have to have the same number on the other side. They can join other in different, they can switch partners and make new compounds, but the same number will be on same side. So let's take a look at one. Steps to balancing an equation. So the formation of aluminum sulfide. This is a metal and a nonmetal. Aluminum sulfide. So it doesn't say how many we have in it. This is one of these things that you're just going to have to know. Write an equation using the correct formula. So they gave us this. It's not balanced, and this is what we're going to have to do. We're going to have to balance it out. So let's take a look at what we have here. We have one aluminum solid. We have sulfur solid, and these are the reactants. And on the product side, we have 2 atoms of aluminum, and we have 3 atoms of sulfur. So you can see, obviously, not balanced. So we're going to have to add numbers to make this balance. And this is where it gets tricky, because sometimes this can take a long time. I have made numerous mistakes where it's taken me more than an hour to balance an equation, only to realize that one small number I messed up on messed up everything, and it really wasn't that difficult. Yes, I have done it many times, not once, many times. So take your time on these, focus on it. If you start getting upset, and that'll happen with chemistry, sometimes erasing and starting over is the best thing. Take a break, come back, start with a fresh, clear mind. These are not meant to be overly difficult, but they are in the beginning sometimes. And sometimes just taking a break actually makes it easier to do when you come back. So here we have, looking at it now, we had 1 and 1 and 2 and 3. So we add numbers. So the first thing I'm going to do here is I have 2 molecules of aluminum. So I'm going to add a 2 in front. And that means I have 2 aluminum atoms on this side. And then I notice I have 3 atoms of sulfur. So I'm going to add a 3 here. And now if I do a tally of it, I have 2 aluminum atoms. And I have 2 aluminum atoms. Not a good thing to say. And then 3 sulfur atoms and 3 sulfur atoms. This is a balanced equation, and you can write it out and you can check it off as you do this. And I'll show you how I do this. So here's another one. State the number of atoms of each element on the reactant side and the product side for the following balance. Now here's the key word. This one's saying this is balanced, so we have nothing to do with this, but you need to make sure you know how to read these. And this is where the subscripts make things difficult in parentheses. So you need to make sure you know how to do this. So we have phosphorus, and we have 4. So I would write phosphorus, reactants, and products. And here we have 4. So I'm going to look at this side. Now this is balanced, so everything should be equal. And I have 4 here, so I'm going to write a 4. Now bromine, I have a 2 here, and I have a 6 in front. That means that I have to multiply these together. So I have 12 bromine atoms. This is a diatomic molecule. In nature, it's found as 2 molecules of bromine together. So this is 6. I have 6 bromine atoms. So that means I need to have 12 bromine atoms. That means I need to have 12 on this side. So notice over here, I have a 3. So 3 multiplied by 4. So whatever coefficient's in the front, you have to multiply it. So this is a 1. So that's why this is a 4, because we don't write 1 out. But as you're learning, if it makes it easier for you, write a 1 out. That's okay. As you're learning this, eventually as you start getting to it, you won't have to do that anymore. But in the beginning, if it helps you, write a 1. So this is 3 times 4, and that makes 12 bromine atoms. And this is balanced. And here's another one. Let's take a look at this one. So I have 2 aluminum atoms, and let's take a look. Oh, so let's look at the reactant. I'm jumping ahead. This is aluminum solid plus iron 3 oxide, which is a solid, produces iron solid, iron by itself, just a solid, and aluminum oxide as a solid. So here we have 2 aluminum. So I just usually start and go across unless something weird is going on. So I have 2 aluminum atoms, so I would write 2. And then I would jump onto this side to C. And I have 2 aluminum atoms, so I'd write 2 under products. So let's look at iron. Iron has 2 iron atoms, so I write 2. And I'm going to look on this side and I have 2 iron atoms, so I'm going to write 2. Over here I have 3 oxygen, so I write a 3. And over here I have 3 oxygen. There's a 1 as a coefficient that when it's nothing's there, that's what we take it as. So this would be 3 times 1, 3. So this is also a balanced equation. So now we're going to balance an equation out. Balance the chemical equation when solid, that's telling you a physical state, of iron 4 oxide reacts with hydrogen gas to produce solid iron and water. So there's a few key things here. This is eventually what you're going to have to do. You're going to be given words and you're going to have to put them in a chemical equation and balance that chemical equation. So here is key things. We have a reactant and it reacts with, this would be the plus sign. So it's reacting with hydrogen gas physical state to produce, there's the words, to produce, to results in, something like that. To let you know there's a final state. Something's happened. So that's the arrow. Solid, iron, and water, and that's a liquid. We all know that's a liquid. So that's why it's not stated there. And if it was a physical state that wasn't liquid, it would definitely state ice or gas. And it doesn't state that here. So I highlighted these. So make sure that you understand that sometimes the word problem gives you everything you need. You just have to pull it out. So here is the equation. I just pulled it out. It's not balanced, but we pulled everything out. So let's take a look here. The solid iron 4 oxide, the hydrogen gas. Now remember, hydrogen is a diatomic molecule. It comes in 2s, found in nature in 2 molecules, not 1. So hydrogen, remember there's 7. Hydrogen, oxygen, nitrogen, the halogens, most of the halogens. It's we can go over that if you need help. Just email me. We can work on that. And so over here we have solid iron. That's what we have here. And water. And that's a liquid. So now we've got the first step. We were able to pull out the information we needed from this sentence. And the sentence provided everything we need. And we have a plus sign between these 2 reactants. See the word reacts. And then we have a plus sign between the products. And an arrow always in the middle. And that faces the products. So this is what I do, is I pull, every instructor's different. This is how I know how to do this. And I believe your book shows it this way too. I write everything out. And I write it symmetrically. So your eyes look at it, it's equals. So I wrote iron, I wrote oxygen, and I write hydrogen. Because some books show you to leave the whole compound, and I honestly don't know how to do that. I know specifically there's another instructor I work with. He shows his class how to do it this way. They leave the whole compound. Don't know how to do that. I didn't learn as a student like that. And then we have iron. So I match it. I don't even worry about how it's listed here. I match it iron, because remember they're supposed to be on both sides, oxygen and hydrogen. Because my eyes will catch if something is not right. If you mix these up, then you make it harder on yourself to see if it's even. So let's do a tally of what we have. So the second thing now is count the number of each element. So you're not doing anything to it yet. You are simply keeping a tally. So here we have 3. Oxygen I have 4. And hydrogen I have 2. Over here I have 1. I have 1 oxygen and I have 2 hydrogen. So this is definitely not balanced. This was what was given in your book. This is how I do it. Okay, so I actually don't know if this was in your book. I sometimes when I don't like what the book gives you, I try to find something easier to understand, because the book doesn't always make it easier for you guys. So this is definitely not balanced. We need to balance it. So I highlighted, I just go down the steps. Now let me tell you one thing I do. This one is by itself. And it's usually hydrogen or it's gas or it's oxygen. I don't mess with this last one. I know there's hydrogen over here. We're going to mess with this. This one is usually the one that brings everything in. It ties it all together. So when there's a molecule by itself, I leave that last. So let's start over here. I have iron. I have 3 of them. So I'm going to put a 3 here. And that's what I did. And I change it down here. So whatever you do up here, you have to change down here as well. Okay, so I did that. I had a 3. The next one is oxygen. I had a 4. So I'm going to add a 4 here in front of the hydrogen. But there's also an oxygen. So whatever I do, I have to change every element that is attached to that coefficient. So hydrogen, oxygen here was 4, because it's 4 times this. So I changed that. But that also affects the hydrogen. So that makes 8. And I changed that as well. And you have to change it. You cannot leave it. Everything has to be accounted for. And then the last one is I can have a 2. I can add a 4. And that makes 8. So this is why I say this is the last one. It's usually helpful to leave it last because it makes it easier to tie everything in. And then now if I look, everything matches. Iron is 3 and 3. Oxygen is 4 and 4. And hydrogen is 4 and 4, and it is balanced. And this is how I actually write it out. I write it right underneath the reactant side. I write this one right underneath the product side. And I usually draw a line. Don't know why. Have always drawn a line. That's just how I do it. So now we're going to do this with polyatomic ions. And by the way, this is a chemical change. Do you see that a color has occurred? It's white. And this is actually a precipitate too. It doesn't, when we talk about solids, we don't mean precipitates have to be rock hard solids. They can be little fine grains of particles, and that's still a precipitate. So there's a huge range of what we consider a solid. All right, so here's an equation that we've been given, and we have to balance this out. And this is where I say other instructors, they take the whole polyatomic ion and they show you how to balance it. I don't know. Everybody that's gone to school, we all gone, instructors, we've all gone to school at different times. And chemistry changes, believe it or not, have the teaching methods to it. So I didn't learn it like that. That would be so difficult for me. So we have this, we have the physical states. So this is sodium phosphate is added to magnesium chloride, which is also an aqueous. So these are 2 aqueous solutions. And what happens when you add them together, it produces magnesium phosphate, which is a solid, and sodium chloride, which is a solution. So these ions are just floating in solution because their partners attached themselves and created a solid. Okay, so this is how I do it. This is an over-exaggerated line, but that's all I could find. It was either really thin or super thick. I draw a line, and I draw it right where the arrow is. And then I write everything out in the order that I see it. So sodium on this side. Sodium. And then I write P. So I break everything up here. I don't leave anything. So P, oxygen, or phosphorus, magnesium, and chloride. And I repeat this sequence on this side. Now I just go through. There is not one like hydrogen gas to leave alone. Everything's attached. So that means that everything's going to be changed probably with everything else. So let's just start and go through it. Oh, I didn't break it down. That's fine. Let me go through and show you here. This is a 3, so this is sodium. And this is 1 phosphorus. This is 4 oxygen. This is 1 magnesium. And 2 chlorines. Okay. Here we have 1 sodium. We have 2 phosphorus. So 2. Do you see this parentheses? This means that it would be multiplied. Whatever's in here has to be multiplied. So 2 phosphorus and 8 oxygen. And also, if there's a number here, that also multiplies it as well. Because that coefficient multiplies everything that's involved. This is a 1, so it's not going to matter at this point. So we have 2 phosphorus, 8 oxygen, and this parentheses only, the subscript 2 only works with what's inside the parentheses, not the magnesium. And then we have 3 magnesium and 1 chlorine. So I did a tally of everything. You can see it's all over the place. It's not balanced. So I'm going to show you how to balance this. So I did break this down in steps now. We have a 3. So here is sodium and there's a 3. So I'm going to put a 3 here. And that's what this is in bold. Here's a 3. But because there's a 3 to sodium, there's also a 3 to chlorine or chloride. So I had to do a 3 here. So that's one compound done. Now, the next thing is we got to look at phosphorus. So if we look at here on the next one, phosphorus, there's 1 phosphorus here and 2 over here. So the next thing I'm going to do is add a 2 in front of the phosphorus here. Now that's going to change everything in this compound. This is why they get more difficult. But they're not impossible to do. It just takes patience. So here I'm going to change the phosphorus to 2, and I'm going to go back and look at the sodium. So now this is 6, and I'm going to now change the oxygen, which is 8. So 6 sodium, 2 phosphorus, and 8 oxygen. Okay. The next thing I'm going to do is change the sodium on this side, because I changed it on this side. So here's a 6. I'm going to put a 6. Now that's also going to change the chlorine. So there is 6 chloride ions. So there's 6 and 6. Okay. So I changed there's 6 here. Oh, did I jump both sides? Okay. So what I did here, sorry, you know what? I put this together. I looked it over, and now I didn't specifically look at certain things. So I put a 6 here. So now I'm going to change, and I'm going to look at the chloride here. So there's a 2, so I need a 3 in front of the magnesium to make 6. So I balance the 6 here. Not everything's balanced yet, though. As you can see, we're still not done. So as I'm going to do the last one, I'm going to do magnesium, and magnesium is 3, and this is 3. So everything, there's 6 and 6, 2 and 2, 8 and 8, 3 and 3, and 6 and 6. So you'll have to jump back and forth a lot, but take your time, and these do definitely have answers to them. Where I've made mistakes is that, like I said, one number was off somewhere, and I didn't catch it, and everything else was just off. I've ended up with coefficients of 52 and 46 and ridiculous numbers that didn't need to be. So here is some practice for you guys. Now, I'm not going to go through these. I want you to go through them yourselves, but I'm going to give you the answers. And if they don't make sense, you are free to ask each other how to do this. You're free to contact me. We can go over this if this is not something that's making sense to you now. So you have everything you need to go through. And what these mean is that means it's a 2 there, a 3, a 2, and a 3. Or is it 2 here, a 3, a 4, and a 3, or is it a 1, 1, 2, and 3? So you're going to pick the best coefficient that matches this. And so basically you have to balance them on your own and then figure out if it's A, B, or C for these 3. And I'm going to give you the answers and with the final balanced equation. And I put a 1 here because if that makes it easier to understand, then that helps. But try to do this first without looking at the answers. And that's definitely good practice for you on this. Okay, thanks.